Welcome everyone. This is Module 1, Homework 1, which is about solving equations. So when you have an equation to solve, like this one for instance, or any equation, there are basically three different things that can happen. When you solve the equation, you can get one single solution, or you can get no solution at all, or your solution can be every number in the world. Now, when I say one single solution, that could mean different things, but we're not going to worry about that in this section. So let's get started. We are going to solve the equation x over 3 equals 5. Well, to solve this equation, you need to end up getting x all by itself on one side. That means we need to somehow get rid of the 3. To get rid of the 3, I'm going to do the following. I'm going to multiply the left side by 3. Now, if you multiply the left side by 3, you have to multiply the right side by 3 also. Since I am multiplying a whole number by a fraction, what I think is a good habit, you don't have to do this, but what I think is a good habit is turn that whole number into a fraction by putting a 1 underneath it. You can always put a 1 underneath anything. That doesn't change, it doesn't change its value. Now, there's a rule about multiplying fractions. When you're multiplying fractions, you can cancel things diagonally. So that allows me to cancel the 3 on the top with the 3 on the bottom. I end up with x over 1. On the right side, I have 15, but anything over 1 is just itself, and that tells me x equals 15, and that is the answer. And if I wanted to check and see if the answer is right, which we don't need to do, but if I wanted to, I could plug 15 into here for x, and I would see that the equation is true. Okay, there's our first answer. That's an example, by the way, of an equation that has one and only one solution. Okay, we're going to solve this more complicated equation. Now, to do that, we're going to end up finding the least common multiple of our denominators. Well, our denominators are 20 and 5. There are various ways to find least common multiple. I'm going to show you one way. This is not necessarily the best way. It's good for some circumstances and not as good for other circumstances, but it always works. If I want the least common multiple of 5 and 20, what I can do is start writing every multiple of those numbers. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15, and so on. If I start writing the multiples of 20, 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60, and so on. I keep going on each list until I eventually see the first number that pops up on both lists, which in this case is 20. That means the least common multiple of those two numbers is 20. Now, I'm not ready to use that yet, but I will be using that soon. So 20 is my least common multiple. So how do I solve this equation? Well, there's multiple ways. One way would be to distribute the 7/20th first. That would give me 7/20 x plus whatever 2 times 7/20 is plus 2/5 equals 3/5 x. I think I'm going to give myself some more room by erasing all this stuff getting out of my way. Okay, so let me rewrite that. I have 7 over 20 x plus, I'm multiplying these. I'm doing 2 times 7/20. Well, again, if you are multiplying a whole number by a fraction, it can be a good idea to turn the whole number into a fraction by putting a 1 underneath it. Now I see there's a 2 on the top that I can cancel with the 20 on the bottom. Dividing them both by 2 gives me 1 and gives me 10. So I end up with 7 times 1, which is 7, and 1 times 10, which is 10. I still have the plus 2/5, and I still have the 3/5 x on the other side. So where do I go from here? Well, this is where we're going to use the least common multiple. So we're going to take both sides of this equation, and as I'm sure you know, you can do anything you want to one side as long as you do it to the other side. I'm going to multiply both sides by the least common multiple, which is 20. So what is that going to give me? That's going to give me 20 times 7/20 x plus 20 times 7/10 plus 20 times 2/5 equals 20 times 3/5 x. Okay, again, if I'm multiplying a whole number by a fraction, it's a good habit to put a 1 underneath each of those whole numbers. These are identical, they match. I end up with 7x over 1, but anything over 1 is itself, so that's 7x. Here I can divide that by 10 and that by 10, leaving me with 2. I will have 2 times 7, which is 14, over 1. Anything over 1 is itself, so that's 14. Oops. Then I have a plus sign. Here I can divide that by 5 and that by 5, leaving me with 4. And by similar reasonings, that's equal to 8. And over here I can divide that by 5 and that by 5, which leaves me with 4. I end up with 12x. So why did I bother to multiply by the least common multiple? Because now I have a much easier equation. Now I have no fractions to deal with. So let's finish this thing up. I'm going to have 7x plus, that is 22, and that equals 12x. I'm going to subtract 7x from both sides. That's going to leave me with 22 on the left and 5x. And then, people often get this backwards, so be careful. Think carefully. You're trying to get the x by itself, so don't even think about the 22 for the moment. Focus on the 5x. You're trying to get the x by itself. How do you get rid of that 5? You divide by it so it cancels. So that's how you know you divide both sides by 5. And that tells you the answer for x is 22 over 5. So that is our final answer to this one, 22 over 5. Okay, let's go to the next one. We're going to solve the equation x equals x plus 1. Well, that's a one-step solution. I can subtract x from both sides. I end up with 1 equals 0. Now notice what happens here. I have an equation. There's no variable in there. If you ever get down to the point where there's no variable in the equation, you got to ask yourself first, is the equation true or false? Well, clearly, 1 is not really equal to 0. So if you're solving an equation and you end up with a false statement, that means the answer is there is no solution. Another way to write no solution is to put a circle with a line through it, which you're welcome to do. I personally hate that notation, but you're welcome to do it. So we can always tell if an equation has no solution when we end up with something that is false. So again, the answer is no solution. There is no number in the world that you could plug in both sides for x to make that true. Okay, let's solve this one. Now, I'm going to tell you a trick that would allow us to skip the step I'm about to do, but first let's do this step. So we're trying to solve it. Well, we can subtract x from both sides. That will cancel there and cancel there. That'll give us 2 equals 2. Again, notice we're at a point now where we have no variables in it. If we have no variables in the equation, then we have to ask ourselves, is the resulting equation true or false? Well, this is true. It is true that 2 is equal to 2. If both sides are equal to each other when all the variables drop out, that means you have an infinite number of solutions. To be more specific, that means every number in the world, every real number in the world, made the original equation true. So one way to say the answer to this is all real numbers. Another way is to say this, which is kind of a complicated way of saying it, but that's another way to express the answer. So this is saying no matter what number you pick for x, if you plug it in here and here, both sides will be equal to each other. So the answer is all real numbers. So if now there's a shortcut to this. If you have an equation and both sides are completely, totally identical, you don't have to go any further. And these sides are identical. They both say exactly the same thing, x plus 2. If both sides are identical, then the solution is all real numbers. Okay, let's move on. We're going to solve this equation. So what could happen? 3 different things. Let me scroll back for a moment. Maybe there'll be one single solution. Maybe there'll be no solution at all. Maybe every single number in the world will make it true. Well, let's see what happens. So I'm going to distribute the 4 here. That's going to give me on the left 2x plus 3 minus x. On the right, 4x plus 4. And I still have the minus 3x and the minus 1. Okay, I got rid of the parentheses. I'm going to combine like terms. I have 2x minus x, that's just x. So the left side is x plus 3. Combining like terms over here, I have 4x minus 3x, which is x. And I have 4 minus 1, which is a positive 3. So now I have x plus 3 equals x plus 3. That tells me what the final answer must be. If you have an equation and both sides are identical, that means the answer is all real numbers. That means any number in the world, if you plug it into both sides for x, will make the equation true. Pick any number in the world, plug it in here for x, here for x, here for x, here for x, and simplify both sides. You will see both sides will be equal to each other. So this is the answer. Okay, we've got a word problem here. It's kind of a 2-part word problem. So this is what the word problem says. You may want to pause the video for a moment and read it. So the question says to find 3 consecutive odd numbers. And these odd numbers need to add up to 249. Well, before I go any further, let's just look at the situation. Let's start looking at odd numbers. 1, 3, 5, 7, 9, 11, 13, and so on. If I look at 3 consecutive odd numbers, that would be something like 7, 9, and 11. That just means 3 odd numbers in a row. So now the question says, as a hint, make x stand for the first number. So suppose x was 7. Then what would the other 2 numbers be? Well, if x was 7, the next odd number is 9, and the next odd number, if you think about it, goes from 7 to 8 to 9. It's 2 more than the previous one, so the next odd number would be whatever x was, plus 2. And the one that comes after that, well, that's going to be 2 more than this one, or it's going to be 2 more than 7, which takes you to 9, and another 2 more, which takes you to 11. So it would be the original x plus 4. So that's what this is saying. The next odd number would be x plus 2, and the next odd number after that would be x plus 4. So the question said that these numbers add up to, so we have our x plus 2, we have our x plus 4, And it says those numbers add up to 249. So this is the equation that we're going to solve. How do we solve it? Well, we have our like terms, x plus x plus x, that's 3x, and 2 plus 4, that is 6. On the other side, we have 249. We'll subtract 6 from both sides. We get 3x equals 243. As I mentioned before, for something that looks like this, we're trying to get the x by itself, so don't look at that for the moment. Ignore that for the moment. Since we're trying to get the x by itself, focus on this side. How do we get the x by itself? By dividing away the 3. Well, if we divide that side by 3, we divide that side by 3. And if we do the math here, 243 divided by 3 is 81. And that is kind of the answer. Not exactly. Let's go back and look at the original question. The original question said to find the 3 odd numbers. That's only one of them. This thing that we found was the answer for x. And what did x stand for? X stood for the first number. So that means our first number is 81. We know there are 3 consecutive odd numbers, so our next number must be 83, and our last number must be 85, and that is the answer to the question. Be careful. Make sure you always answer the question being asked. If you were to do this problem on a test, and you were to tell me the answer is 81, and you showed me all this work, I'd probably give you some partial credit, but I wouldn't give you full credit because you didn't answer the question. This is the answer, not just 81. This is the answer, all 3 of those numbers. Okay, let's move on. I recommend you pause the video and you read this question. Okay, so the question says that you're buying a new phone. It says, including tax, your phone is going to cost you this much. They also tell you what the tax rate is. The question is, what was the price before tax got added? I think most people, unless they've done something like this before, their intuition is wrong. So you don't want to go with your intuition on this thing. Before we look at this problem, let's take a look at how tax works. So suppose you had a similar scenario. Suppose you're buying a phone, and suppose the phone cost $250 before tax. And suppose the tax rate was 8%. Let's see how you would find the final price. Okay, so how much tax would you pay? Just the amount of tax you would pay, I hope you know because you hopefully have done things like this before, is what you get when you find 8% of 250. How do you find 8% of 250? You multiply 0.08 times 250. And let me grab a calculator and do that. 0.08 times 250 is $20. So the phone costs $250, but there is an additional 8% tax. The 8% tax becomes $20, and so the final cost of the phone in my new scenario is $250 plus 20, which is $270. Now think about what's going on here. This is the original price. This is the amount of tax that you'll pay, and this is the final price. So we have a formula that says the original price plus the amount of tax, which I'm going to leave out for the moment, but this line is going to have to do with tax, equals the final price. Now, how did we figure out the tax? Well, the way we figured out the tax was we multiplied the tax rate by the original price. So the number that ended up on this line, the $20, came from the tax rate multiplied by the original price. This is our formula we're going to use to solve the actual problem we're supposed to solve. It's always going to be true that original price plus tax rate times original price equals final price. So we're going to use that formula to solve our problem. Okay, now let's do the problem. And let me do a little bit of erasing here for a moment. My eraser is acting strangely. There we go. Now it's acting correctly. Okay, so let me just copy down the formula. The original price plus whatever I get by multiplying the tax rate times the original price will be equal to the final price. So what do? I just plug everything in. Do we know the original price? No. That's the thing we're trying to find, so I'll call that X. Again, we don't know the original price, so I'm going to call that X. It's supposed to be multiplied by the tax rate, which is 0.06 or 0.06, however you want to write it. And that's equal to the final price, which we know is $462.16. So this is the equation we're trying to solve. Okay, before I go further with this, just want to point out a couple things. First of all, anytime you have a variable with nothing in front of it, that's the same as having a 1 in front of it. So I'm going to put a 1 because I know in a moment that's going to be useful to me. I want to do one other extra thing before I continue. I have a question for all of you. My question for you is this. What is 2x plus 3x? I'm sure you know the answer. The answer is 5x. I'll explain why I'm asking you this in a moment. So how do you add two things together that both have an x on them? Well, you just copy down the x, and where does the number in front come from? It comes from adding the two front numbers. So what do I get when I add these two things together? Well, that's the same idea as this. They both have an x on them, so I'll end up with an x. And how do I figure out what number goes in front? I just add these together. And what is 1 plus 0.06? Well, that is literally 1.06 when you add them together. So the left side is 1.06x. The right side is 462.16. As I hope you understand, to get the x by itself, I divide by 1.06. So I divide both sides by 1.06. I grab my calculator and I do that calculation. 462 divided by 1.06 is 436. And that is the answer. That is what the price would have been before tax, $436. Okay, let's move on. Let me just get this out of our sight. Let's move on. Okay, we have a formula. And the question has two parts here. The first part of the question is, what would W be equal to if you plug in 5 for D? Well, that's pretty easy. You just plug in 5 for D. So you get 2 times, instead of D, 5, plus 1, equals, and while I'm at it, I'll distribute the 3W minus 6. Then we just solve this thing for W. Well, that's 10 plus 1, so that's 11, equals 3W minus 6. Add 6 to both sides. That gives me 11 equals 3W. And pause the video for a moment and just do the one last step here. Okay, I hope you did the last step. Again, when you see something like this, focus on the fact that you're trying to get the W by itself, so ignore that side for the moment. How do you get the W by itself? Dividing by 3 to get the W by itself. So that means divide that by 3, and the answer is 17 over 3. So the answer to the first question is the fraction 17/3. Okay, now we're going to do this. We're going to find a formula for W. Let's see. Think about whether or not I want to erase. I'm going to hope I have room here. So let me copy down the original formula. The original formula is 2D plus 1 equals 3W minus 2. So our goal here is to get the W completely by itself. Well, there's no way you will ever get a variable by itself if it's in parentheses. So the first thing I'm going to do is distribute the 3. It's going to give me 2D plus 1 equals 3W minus 6. Now the W is no longer in parentheses. Well, I need to get rid of the 3 and I need to get rid of the 6. I can't get rid of the 3 yet. I mean, there is a way to do it, but it's not a good... It'll make things more confusing. I'm not in a situation similar to this. I don't have just 3W by itself, so I could divide by 3. So what I need to do first is get rid of the 6 here. Well, you know, if you're subtracting 6, you can add a 6 on both sides to cancel that. I now have on the left 3W by itself. On the right, I have 2D, and I have 1 plus 6, so that's 7. Now I'm in a situation similar to this. I have 3W by itself, and by the same reasoning as before, I can divide both sides by 3, and there is my answer. That is my formula for W. W is 2D plus 7 over 3. Now, why would you want to bother to do this? Why would you want to solve an equation for a variable? Well, not to be too long-winded here, suppose you often want to do with this equation what we did in this case. Suppose you often want to know the value of W when you plug in D. Well, that was a lot of steps to do that plugging in 5. I mean, it's not rocket science, but it was still a lot of steps. If you have a formula for W, you can do everything we did here in one step. You simply plug the 5 in here, and you'll immediately get the answer. You don't have to do any solving of equation at that point. So that's why. You don't really have to know that, but I just thought I would throw that in. So there is the answer. That's what you get when you solve for W. Okay, we have one last problem. Is that the last one? Yep, we have one last problem, and then we're done. So we're going to solve this equation for M. Now, a moment ago I told you if you ever have a variable you're solving for, it's in parentheses, there's no way you'll be able to solve it until you get it out of parentheses. Well, if you're solving for a variable that's in the denominator, there's no way you'll ever be able to solve the problem until you somehow get it out of the denominator. So here is how I'm going to start. I got k on the left side, and I've got 2 plus x over m plus 1 on the right side. If I want to get the m out of the denominator, there is no reasonable way to do it besides taking the m plus 1, the whole thing, out of the denominator. How do I do that? Well, I'm going to multiply the right side by m plus 1 over 1, which is the same as just saying m plus 1. Because I know since the top and the bottom match exactly, they're going to cancel. And since I multiplied the left side by that, I multiply the right side by m plus 1. Now, you might be asking yourself, why did I do over 1 on this side? Why did I put the 1 down there on that side? Why didn't I put it here? Well, I can if I want, but I'm multiplying something that's not a fraction, so I don't need to multiply it by a fraction. So I'm just going to leave it as m plus 1. Now I can distribute the k. That's going to give me km plus k equals 2 plus x. Okay, Imagine, this is not what we have, but imagine we had km equals 2 plus x, and you're trying to solve for m. Well, we could now do that because, as you know, we can divide by k to get rid of it. So if we just had km, we would be good. But we don't have just km. Somehow we need to get rid of this k that's right here. How do I get rid of the k? Well, since the k is being added, I subtract it from both sides. So I'm now going to have km, because those cancel, equals 2 plus x minus k. I need to do one more step and I'm done. I am solving for m, so I will divide both sides by k. And I end up with m equals 2 plus x minus k over k. I'm 100% fine with that answer, but there is another way to write it, even though this is 100% fine. Anytime you have a fraction that has plus or minus in the numerator, not the denominator, but the numerator, you can always split that fraction up. So I can split this up into 2 plus x over k minus k over k. And there's nothing really good I can do with 2 plus x over k, so I'll leave it alone. But k over k, anything divided by itself is 1. This is another way to write the answer. So there are two acceptable answers to this question as far as I'm concerned. One is writing it this way. The other one is writing it that way. Couple things you need to know about these kinds of problems. When I say, excuse me, these kinds of problems, I mean problems where you have an equation with a bunch of different types of variables and you're solving for one variable. First thing you need to know is this: do not change the case of the variable. Don't change uppercase to lowercase, lowercase to uppercase. In other words, don't change that to a lowercase m, for instance. I won't go into the reasoning, but just don't do that. Another thing is this: when you are solving an equation for a variable, like in this case we're solving the equation for m, you need to end up with m on one side, and the other side is going to have some kind of formula. And the rule about that formula is it's not allowed to have that same variable on that side. In other words, if we were solving this equation, and let's just say, I'm just going to pull this out of the air, let's just say I said the final answer was m equals x plus m over 2k, that could not be right. When you're solving for a variable, that same variable is not allowed to end up on the other side. There's a good reason for that, but I don't want to prolong this video by going into that, so just be sure that you do not do that. Okay, that is the end of this recording.